In this video, we're going to be evaluating the voltage drop across this resistor and this resistor using Kirchhoff's laws, and also the power dissipated in the 12 ohm and 40 ohm resistors. So the first step we take is that we assign polarities to the resistors that do not have polarities yet. After that, we assign currents to the branches that are yet to have currents. Let's make this I3 and this one I4. Okay, so we can write a KCL equation as this node, and that would be KCL. So that would be I1 plus I3 equals I2 plus I4. Sum of currents entering a node equals sum of currents leaving a node. Let's call this our first equation. Also, we can identify three loops in this circuit. The first loop 1, loop 2, and loop 3. We can write the KVL in each loop. And let's write the KVL in loop 1. KVL loop 1. That would be, starting from here, we get I3, that's 6I3. 6I3 plus 6I3 plus 10I4 minus 15 equals 0. Notice that we start writing from here, and then the sign of the coefficient is the polarity that we encounter first as we start from here. Next, we can rewrite this as 6I3 plus 10I4 equals 15. Let's call this our second equation. Then we write the KVL for loop 2, and that would be 40I2 minus 10I4 equals 0. Then we can therefore say that I2 is equals to I4 divided by 4. Let's call this our third equation. Then let's take the KVL for the third loop. Then that will be KVL loop 3. So we have plus 12I1 minus 6I3 equals 0. We can then say that I1 equals I3 divided by 2. Let's call this our fourth equation. Okay, so we can go back, we can substitute our third equation and our fourth equation in the first equation, and that will give us I3 divided by 2 plus I3 equals I2 plus I4 divided by 4. And then we can multiply through by 4. That would give us 2I3 plus 4I3 equals this should be I4 equals 4I4 plus I4. Then we sum them up, then we have 6I3 minus 5I4 equals 0. Then let's call this our fifth equation. If we proceed to solve this equation simultaneously with the second equation, we arrive at I3 being equals to 0.833 amperes and I4 being equals to 1 ampere. By this, we arrive at I1 to be equals to 0.41665 amperes and I2 equals to 0.25 amperes. Then we can say that our voltage V1 equals 0.41665 times 12, and our voltage V2 equals 0.25 times 40, and this should give us approximately 5 volts, while this gives us 10 volts. As for the power dissipated in the resistors P1 and P2, that would be I1 V1 and I2 V2. That would mean 0.41665 times 5 and 0.25 times 10. Arrive at 2.08325 watts and 2.5 watts. Thank you for watching. If you found this video helpful, please like and subscribe and share with others. Thank you.